Hello, and welcome once again to another episode of Interesting Stories in the History of Diagnostics from Halteris Associates. This is Mickey Urdea, looking forward to talking to you about environmental DNA, or eDNA. I find this to be a particularly interesting topic. So, environmental DNA, what do we mean by that? We're talking about DNA that can be found just about anywhere. In fact, I think one of the most surprising things in the last many years is just how much DNA there is to be found. We can find it in the snow. We can find it in permafrost. We can find it in the soil. We can find it in water. We can find it all over the place. And it's representing many different types of organisms that have been there recently or in the past. Plants, animals, fungi, bacteria, whatever you want. I want to talk a little bit about how this is being used and the potential of it in diagnostics, but a little more about just the eDNA itself. Another place that it has recently been discovered, and very interestingly, is in the air. People have tried this in the past, but I think the technologies have gotten better for actually detecting DNA in air. Recently, a study was reported by Christine Bowman, Associate Professor of Evolutionary Genomics at the University of Copenhagen. And what she did was a very interesting study. She set up 3 large filters for 30 hours outside of a zoo. And when she did that, she found DNA from all kinds of organisms, over 30 types of mammals, over 13 different kinds of birds, 1 amphibian, 1 reptile, and 4 fish. One of them was a guppy that lived in the tropical house in the zoo, and the others, I think, were actually from fish feed that was being used to feed other animals. So they found the DNA from the feed itself. Some of those animals were actually, and most from the zoo, but also things like squirrels and things running around. So they're finding it all over the place. Very interesting. Another rather interesting application of eDNA from a few years ago was from people at Microsoft Research. They had this concept of capturing mosquitoes in the environment and testing them for viruses. And what they came up with was a very interesting looking little device that they could place out in the middle of nowhere. It had 60 little props in it, open doors where a mosquito could fly in, find some sweet water in there. They had developed these IR sensors to determine what species of mosquito they were finding and whether or not they wanted to close the door on that particular species. Then they took all those mosquitoes back to laboratory and sequenced them. So this is sort of an extreme sense of eDNA. They found more than 70 different types of viruses there. They also found human DNA in them from people they had bit over the time. eDNA is also very popular in the field of ecology. There are many people that actually send their graduate students out to take samples of soil in particular. And I was at a research conference at Northern Arizona University a few years ago, talking to one of the students in forestry, and she had gone out and taken core samples from soil in various forests, brought those back, and then did DNA sequencing at different levels down into the core for looking at differences in the biodiversity of animals that were present in the area over time, back for a few years, which is very interesting. You know, we can only go back so far with this because of the problem of the stability of DNA over time. DNA has a T1/2 of about 521 years, was reported in a 2012 paper in Nature. And so every 500 years approximately, half the DNA is broken up. Half of the bonds within the DNA are broken up. So you can't go back as far as you'd like to, which is one of the reasons that all these studies in the past of amber and organisms in it only go back to about 500,000 years maximum that you can actually do it. Past that, the DNA is degraded. Sorry, everybody who wants to see Jurassic Park happen, ain't gonna happen. So eDNA, lots of different applications of it, lots of different ways it can be used. One of the ways that it's being used more commonly today is in wastewater to determine the presence of pathogens in the environment, human pathogens. I've seen this for several years now, particularly in so-called neglected tropical diseases such as schistosomiasis, onchocerciasis, in areas where it is endemic, and looking at wastewater to determine whether programs to eliminate it in the area have been successful or not. You don't need a lot of it. And what you've probably seen reported in newspapers is that it's being used now to look for SARS-CoV-2 and coronaviruses in general in the presence of wastewater. There are a number of companies like QIAGEN and Thermo Fisher that are now actually producing kits for people to use, and they can do amplification of it using PCR. They can do sequencing of it as well. And it's gotten to the point now where you can take a sample from wastewater that's from a building of, let's say, 100 people. Could be a dormitory, could be assisted living facility, could be an apartment. And if there's one person infected in there, you will find them with sampling the wastewater. So it's becoming quite sensitive. So this is a very interesting way to expand beyond what we're doing today. You know, the other thing you could obviously do is you could test the human DNA in those same wastewater samples. And you could, I don't know why you'd want to do this, but you could probably actually find cancer present within that population. You can also do something that people have been speculating for some time, and I think it's doable now, is identifying the people in that facility based on their DNA, which is a bit of a concern in terms of the privacy ramifications of that. There probably are things that we can do but shouldn't, but just the capacity of being able to detect that eDNA in various places means that not only in wastewater, but could find who walked down the street recently, who's been recently in this car. There are lots of possibilities that can be imagined where you can find DNA almost anywhere you want to look. So thanks once again for listening to another episode of Interesting Stories in the History of Diagnostics. This is Mickey Urdea for Halteris Associates. Thanks very much for your attention, and I'll talk to you next time.